Good afternoon. Thank you for joining today's webinar featuring LPCiminelli. It is my pleasure to introduce you to today's speaker, Tim Kelly, Product Manager at Assemble Systems. Go ahead, Tim.
Thanks, Samira. So today what we're going to do is actually allow LPCiminelli to focus on their use case of Assemble and some of the things that they're doing in estimating with building information modeling. So today I have with me Melinda Hoffman and David, and what they're going to be doing is going through their challenges and benefits of using models during takeoff, and then walk through a couple of different case studies and the lessons they've learned there. Then once we've wrapped up the content, we'll open it up for questions and go through those as necessary. So first, I'll just introduce myself. I'm the product manager here at Assemble. My degree is from Texas A&M in construction management, and I've spent the bulk of my career in the industry in both pre-construction and in construction using VDC, Virtual Design and Construction, and BIM, and estimating and project management. So with that said, I'm going to go ahead and kick it over to Melinda to introduce herself.
Good afternoon, everyone. My name is Melinda Hoffman. I'm the Virtual Construction Director at LPCiminelli. I've been with LPCiminelli for 5 years, incorporating BIM into the construction process. Before that, I was with an architectural and engineering firm for about 8 years. I've been working with BIM and VDC now for almost 13 years in the industry.
Good afternoon, everybody. My name is David Nachreiner. I am the VDC Estimator with LPCiminelli. I have been with LPCiminelli for a little over 2 years. I hold a degree in construction management as well as drafting and design. I was brought on by LPCiminelli to be a liaison between the virtual design and construction department and our estimating pre-construction services.
Perfect. Thanks, guys. So before we do start, I just want to give a quick overview of what Assemble is. Ultimately, we're a web-based platform that allows you to access your models and share with your project team. Within Assemble, when you publish your models out of the authoring systems, you have direct access through any web browser to get into the model, filter, sort, and query it based on any property set that's built into that model. In addition to that, build other properties in and manage your model across the life cycle of the project. So for estimating purposes, which is what we're focusing on today, you have the ability to aggregate different quantities based on different property sets. So if you're interested in looking at maybe the total cubic yards of concrete, you can set up your data so that you can organize it and get that information out very, very quickly. So once you do that, you have the ability to share it across your project team. So Melinda and David today are talking about their use and then how they ultimately share with the rest of their team. So with that said, Melinda, you want to go ahead and jump right in?
Thank you, Tim. So just a little bit about LPCiminelli. We have been in business for over 50 years. We have offices in New York City and Buffalo. We have around 200 employees. We also have some international experience. Last year we were ranked New York State's number 9 in ENR, and we have done over $700 million worth of work last year. Some of our more notable projects, a couple of them we'll be talking about today. We completed a 1.4 million square foot solar panel manufacturing facility last year, which was quite a feat, and without VDC we wouldn't have been able to complete that project on time and on budget with all the complications that came up for that particular MEP systems. A couple other ones, we were working on a 1.5 million square foot casino resort that we will talk about in a little bit as well. A 680,000 square foot medical office facility, or a medical science building for a university. All of these where we're using VDC, Assemble, and estimates out of the model. So we'll give you a little bit of insight as to how we've been using them, some of the things that we've learned over the past 5 years that I've been here and the 2 years that David's been here, and how we've improved upon our process. So when I first came on board 5 years ago, one of the tasks was to work with the estimators and start moving them from the old paper ways with on-screen takeoff, counting doors by hand, into using the models that we were starting to receive. The one thing that we got pushback on was, well, this is how we've always done it. One of the other things was they had trouble understanding and trusting the data that we were giving them. So we had to start with some low-hanging fruits. We had to validate and prove everything that we did, and it was a very slow and steady process. But over the course of the last 5 years, we've really come a long way from the old only on-screen takeoff and paper method. One of the first things we found the most value in was getting estimators to look at the concrete and steel. The accuracy was really high when we could grab steel quantity takeoffs and for concrete, as well as being quick to model inside of Autodesk Revit. Parking garages became kind of a specialty. We had a whole bunch one summer, and we were starting to model them ourselves. We had a parking consultant that would send us some drawings. We would model those ourselves. And by modeling them quickly, we could see different alternatives and options, pull out cubic yards of concrete, and take those to our estimators, who then would put them in as different options and value-added options, finding ways we could improve the design and keep the costs down. Same with the structural steel. It is very quick and easy to model basic steel in Revit, and being able to take the tonnage off was something that was quickly verifiable and easily modeled. One of the biggest hurdles was the two-way education. And what I mean by that is, as somebody who was more of a modeler, architectural background, media background, understanding the modeling side of it was very easy, but understanding how the estimators viewed the model was something that took a little bit of learning. As a modeler, we needed to understand what it was the estimators really needed. The estimators needed to understand what wasn't available from those models for takeoffs, such as excavation and backfill. Which tasks were time-consuming in 2D takeoff was something we as modelers needed to understand to see if we could do them quicker and easier and more efficiently inside of Revit, such as tonnage, exterior skin finishes, and tracking potential change orders. Revit categories and uniformat became something of a challenge. Our estimators were very used to seeing it one way, and Revit only does it one way. So that became a challenge to understanding their needs. And I'm breaking down the building for estimation purposes, and I'll have David talk a little bit about some of the pictures that you're seeing on the screen.
Thanks, Melinda. As I'm sure a lot of us are familiar with dealing with estimators, we look for shell core, exterior skin, volume, and BGSF are some typical things we initially look at when we're trying to take a job off, especially at the schematic level and all the way up through the CD level of documentation. If you reference the bottom right-hand corner of your screen, you'll see a model. We'll take a look at this model again later in the presentation. However, this represents a project that we're currently building. It consists of a casino, a hotel, an underground and above-ground parking garage, and some back-of-house spaces. Utilizing the model and breaking out the model into the specific program spaces and then showing that visually to the model, to the estimators, allowed them to better understand what kind of scope was held within each project area. And it was a good segue into utilizing the model and pushing it into the overall workflow of the pre-con and estimation services. If you reference the top left corner of your screen, this was a takeoff we did once we were awarded subcontractors. We took their scopes of work and provided them a color and did a takeoff based on the scope of work per that contractor. And this allowed our estimators to visually see in 3D, the 3D shell, the skin of the building, rather than looking at it and taking it off on a 2D sheet.
So David, when you're sharing that information out and they're able to see it in 3D, what's the typical reaction? Is it do you see that people understand the project more quickly?
I think it creates a different flow of communication from the 2D page to the estimator. It allows them to visually see what the scope of work represents, and it not only gives the estimator and or the subcontractor in this example a 2D sheet showing where their scope limits were or start and stop, but it also allows them to visually see what they're going to be building from start to finish.
Yeah, that's absolutely great. When you're thinking about how many sheets are probably on this project, being able to, in one shot, look at your entire scope of work and kind of consume it that way. Yeah, absolutely.
Absolutely, Tim.
Thanks, David. So when I came to LPCiminelli, one of the first things that was evident was creating templates for the estimators. I had begun the process, and when we brought David on board, he really began to refine it. So I'm going to let him talk a little bit about the model templates that we've worked on creating in Revit to help us better have that easy button, that big red Staples easy button, so that when we create a model in-house, we can send something out that's usable.
Sure. That was really, thanks, Mindy. That was really one of my biggest challenges initially, was trying to figure out a way how I can communicate between our VDC department and the estimating department. And the first thing I needed to find out was how did they compose their estimates? How did they like to see the information? How did they like walls organized? How did they like partitions organized? Ceilings, floors, doors, soffits, everything from the outside of the building to the inside of the building. As we all know, we get models sometimes from a design team, and they're either really, really good or really, really poor. However, they're not perfect, and we can't use them directly out of the box. So it's important that we decided to come up with templates, so that way when we produce information out of our models, that it was a language that was readable to the estimators. So we composed typical wall types, typical floor types. Our naming conventions we used represented SD level documentation, DD level documentation, as well as CD level documentation. And it really helped us organize the information that Revit produces to a format that the estimators were familiar with and understood.
Great. So along with that came vetting models. So like David said, we would receive models from architects and engineers, and we really needed to understand how well these models were put together. Some of the things like wall functions, floors, and roofs. And David can talk a little bit more about creation of a spreadsheet to vet models and understanding the quality.
Yep. Thanks, Mindy. So one thing that we found in most models we receive is that sometimes the building information, the building components or families as they're called, aren't utilized correctly, or their properties aren't utilized correctly. So for example, if I was creating a wall schedule and I wanted to sort my wall schedule by interior function and exterior function to represent my interior partitions and my building shell, I would create a schedule. However, if I wanted to organize it, sometimes that function wasn't used correctly. So we wanted to make sure that if we were producing wall schedules for our estimators, they were organized in a way that they could read and that they could be accurate. So using the specific properties for walls for function is one thing we would look at. Also, a lot of the buildings that we build, there's exterior balconies, exterior canopies, outdoor spaces that are suspended or built off the exterior shell of the building. And a lot of the models, the flooring of that balcony will also be the same flooring as the slab on deck for the interior of the building. And stuff like that, those two examples are estimated separately. The estimator would look for a square footage and volume for the balcony and a separate square footage and volume for the interior space. The interior space represents the overall BGSF of that floor, whereas the balcony represents a different quantity. We ran into this similar issue with soffits. A lot of times in the models that we receive, even at the CD level, the soffits, or the wall that represents the soffit, isn't actually modeled. So we would ensure that A, we modeled it, or it was modeled, and B, that wall type that represented that soffit was separated from the overall interior wall types, just because that the estimators provide a different charge to soffit construction than they do typical interior partition construction.
Great. Another thing that we found a lot of were not just wall functions, but door functions as well, whether they were interior, exterior, being separated. They need to be classified if they're fire rated, as well as any other specialty kind of doors that needed to be labeled and estimated separately. Another one was the height of walls. Pulling off the quantity of walls, if you were trying to use the area for anything such as drywall or paint or whatever, you needed to make sure that those walls were modeled if they were supposed to be full height or if they were supposed to stop above the ceiling. It makes a big difference in an estimate.
Yeah, I just kind of to jump in really quickly as you guys are talking through that. You started off this conversation with hearing from different people in your organization the typical phrase, that's how we've always done it. And what I want to point out to here, as you guys are talking through vetting models and conditioning data so that it matches what they expect to see, making it comfortable for them and usable, garbage in, garbage out, you want to make sure that it's quality information. What I'm hearing you guys say, and I won't ask you to give a specific number or time savings on this because I know it's really difficult to do. But what I'm hearing though is that there's, in the way we've always done it, there's enough inefficiency there that you guys are able to go through, condition this information and get value while still saving time from the traditional approach. Is that accurate?
I would think so.
Absolutely.
When we first started, obviously the process was a little bit more time consuming because we were still getting that communication down between us and the estimators, understanding what it was that they were looking for, understanding how we needed to tweak our templates so that we could easily transfer those parameters into a model we received or whatever it might be. So over the course of the few years, we've become more efficient at this process, and that has allowed us to much more easily hit that button. So when we receive a model, we can send it out.
And Tim, just to add to your point too, I think one of the neatest things with being that liaison between the VDC department, our department, and the estimators is I've only been in the construction industry for 8 years, 6, 7 years maybe. I'm dealing with some of these estimators in our company that have been here for 30 years, or they've been in the industry for 30 years. So these guys are a wealth of knowledge, and
Sure.
Not only are they benefiting from getting the information out of the models, but I'm benefiting by learning from them, the tricks of the trade, some of the things that worked and didn't work when they do their takeoffs. And then I can then apply some of those methods to how I analyze and vet the models we create or the models we receive.
So with that, we're going to jump into the case study part of our presentation. And the point of this is to kind of talk about ways that we've utilized the technology, the models, the parameters, as well as Assemble over the course of the past 4 or 5 years to help us with estimates in situations that were maybe a little bit different, or each situation for each project was a unique way of using it. The first one we're going to talk about is a medical office building. It was 350,000 square feet. It was a core shell for the phase 1 and then a tenant fit out for phase 2. We received the model from the architect at every design change. So in this project we were partners with the developer, so we were able to have a lot more control over what it is we were receiving and how we were involved with this project. The first issue with this project was nobody could give us a definitive answer on how many floors they wanted. First they wanted 8, then they dropped it to 7, then they dropped it to 6, they went back to 7, and then at the end of the day they decided to do the GMP on 6 floors. However, keep the foundation designed for if they would add the 7th floor at the last minute. You can see in the image below the 6th floor design and the 7th floor design and how they differ just a little bit. One of the biggest challenges with having the flexible building for the estimators was this particular building in general had a lot of bump outs and facades, and so the estimates became a little tricky. When we received the model, we were able to take a look and vet this model, and at the beginning we found that work sets weren't assigned correctly, wall functions weren't assigned correctly, some of the interiors were assigned exterior, some of the shaft walls were not assigned correctly that we needed to take off separately as well, because when we're estimating for a core shell and a tenant fit out, we have to be able to separate those quantities. The GMP was created on the 6th floor, and very shortly after, they finally decided to add the 7th floor back in. With that happening, the steel needed ordered within days, so we needed to take and create that estimate very quickly and easily. We were very, very lucky and fortunate that the architect was really willing to work with us on this project. I was able to communicate with them some things that they could change in their parameters or their functions for work sets to allow us to be able to get these new models that they were sending us daily during this design process and pull those quantities out quickly. We were able to isolate entire floors like the 7th floor as shown in the highlighted picture here so that we could take that floor off separately to know what that was going to add to the cost of the building for that rental fee. The structural model was also divided into separate floors so that when they called and said, okay, we're adding the 7th floor, we got to order the steel, we were able to tell them exactly what they needed within a day or two of request, where the old way would have taken a lot longer to figure that out. This particular project, when we started vetting the model, we were running into things like David had mentioned earlier, where the roof was the same as the balcony bump outs and the same as the underside of the balcony bump outs. So those were things that we worked back and forth with the architect. If they weren't able to change those, we would change them on our side before pushing out those quantities. But at the end of the day, it became a big success and a huge cost and time savings being able to utilize their model for each particular iteration of design that we needed to take off. The second project I'd like to talk about was a hotel project. This was a 135,000 square foot hotel, nothing real fancy, but they wanted it to be very fancy, such as a 5-star hotel, but only had a 3-star price tag. Initially, this project was $2 million over budget, and they came to us and said, what can we do to get that down? So we completed the model in-house because we were not provided, as with most proposals and beginning stages of design, we're not provided a model. And so we modeled the whole exterior and then a couple of interior rooms as a starting point. We used this model to help value engineer the design to find different ways to save money. The estimators had come to me and said that there was a big cost in the windows for this hotel. Originally, the windows were designed to be wall-to-wall in the hotel rooms and almost floor-to-ceiling, just leaving enough room for the units up below the windows. Being very costly, they asked me what we could do to quickly show the differences in cost with the model. So we took the original windows, and with Revit, as you know, when you change it one place, it changes it everywhere. So we took the quantities off for the walls and the windows, and I changed the window size down by about a foot or so in each direction, and immediately got the quantities for the new one. We were able to save $250,000 with that one change that in Revit literally took 5 minutes. And then we also did some renderings, as you can see on the bottom right, to show what that room would look like and feel like with the smaller window. Once you add the curtains into the space, you really don't see the extra foot or two on the other sides of the window because it's covered by the curtains. This really helped to knock that $2 million down a little quicker and easier than trying to find little ways here and there. So we mentioned a little bit earlier, and David had mentioned a little bit, that we would be talking about the casino resort we were working on. It's 1.56 million square feet, and we did receive the model from the architect and the engineer in this case. When we received this model originally, we started about, I would say, 5 or 6 years ago getting models and getting information for this project. The initial takeoffs that we needed to do were the foundations and the steel. The nice thing was the foundation model for this project was done very well, and we were able to quickly take off the quantities as well as verify those quantities. And with getting design changes every week, we were able to save the foundation estimator alone 8 hours worth of work each time we received a model. The steel takeoffs were the same. We were able to analyze the tonnage, compare it to what they were getting, but also use that steel takeoff to understand the best location to put a tower crane. By figuring out where the biggest size pieces of steel were, we could determine if one tower crane could lift them or the best placement for that tower crane. We could also determine if we needed to rent a crane for a week to move some pieces or if it would just be a day pick. This helped us to refine our budgets and refine our estimate, understanding that we might not need 2 tower cranes or we might not need a secondary crane for 3 weeks. With that, I'm going to hand it over to David to talk about how we've utilized Assemble with this casino resort.
Yeah, thank you, Mindy. If you wouldn't mind going back a slide, I just wanted to reference one of the pictures in here. Yeah, so with that being said, this project was really the first project I really relied heavily on Assemble and the different tools that Assemble offers. Because of the size of this project and all the different program areas, we were tasked to divide the model up. We decided to divide the model up within Revit into our respective program areas, hotel, casino, back of house, parking garage. And we utilized a few different parameters that we created within Revit, the text fields or the comments fields, gave the specific building area component or a parameter, and then published it within Assemble. If you look at the top right corner, that's an example of how we applied all the steel that would build the hotel. We applied it a name and a color. That way, once we published the model into Assemble, we could create specific views and isolate those building components to provide a takeoff and a comparison to other iterations of models. Thanks, Melinda. That was all on this slide. So one of the interesting things with this project is the amount of models that we get from the design team. Because this is such a massive project, a lot of the areas in the building are still being designed and decided upon as we're building, the core shell, the superstructure, and the exterior skin of this building. As these design changes come about, or as the design evolves, the design team has given us, at times, weekly model updates, and also bi-weekly or once-a-month model updates. At this point in time, we have about over 50 models per all trades, so 50 models for architecture, structure, and MEP systems. Getting all these models and comparing all these models or all these changes is a huge task for our estimators. One of the big things that started changing right away was the steel sizes and tonnages. And as these bulletins were coming out, the estimators were having a hard time keeping up. Bulletin 37 would come out and the estimators were still taking off Bulletin 28. So we utilized Assemble to publish the weekly publications and then compare them to the previous to see what changed, what was added, what was removed. This saved an exorbitant amount of time for not only the estimator but also for myself, because as we were finishing up the comparison, we were getting another model and we were ready to go for that one. I would say at this moment in time, we've identified about $2 million in additional steel that was added after our GMP was established. And it's really been helpful to not only track the amount of those changes, but also the time it saves the estimators utilizing a combination of Revit and Assemble.
Yeah, I'm just going to jump in real fast on that. 50 bulletins, 50 model versions across all those different disciplines. That sounds pretty overwhelming in any estimating practice. But David, you talked a little bit about being able to run the comparison and show the changes really quickly. Were you able to sit down when you were doing that? You guys were driving through the model and you're providing quantities after reviewing that model with your team, or can you add a little bit on that process of how you were sharing that data?
Absolutely. So within Assemble, obviously we have the tool or the opportunity to compare models or to run a comparison between iterations of models. It's one of the my favorite aspects of Assemble and one of the biggest reasons why I use it so much. So what we would do is we would compare model Bulletin 44 to Bulletin 40 to see where the changes were and to identify where the changes were within the specific program areas. We all get those 2D drawings that have clouds written all over them and they show where the changes are, and you get some notes and it tells you what the changes are. But really utilizing the model allows you to check the drawings and check the drawings to the model to see if they make sense. Once we compared the models and we produced a report showing the adds and the what was removed, we composed a template within Excel that had a cover page, and it just had some brief information, project number, what scope of work was being compared, and also what models were being compared along with their date. And then on the backup pages we showed changes in structural framing, and we would also show changes in structural columns, and any angles or plates or other supplemental steel that was within those areas was also accounted for. And by sending that report out, it allowed not only our estimators to make the required changes, adds and deletes, but it also went out to the project team in the field so they can actually see what's changing as it's being hung in the air.
That's awesome. That sounds like a great workflow.
Yeah, it's a quite a daunting task when you're getting this many bulletins and this many models. And without the aid of Assemble's compare utility, I don't know that they would have the opportunity to still be working through these bulletins.
We'll be on bulletin 3.
One of the other things that happened during this project, David was actually out of the office, and I received a phone call saying, hey, here's the deal. We never had a design for the top floor of the hotel for mechanical piping. We've gotten a model, which is their accepted design, but we need to take it off to understand what the PCO and the CO is going to look like. So we had a change order that was coming. We needed to have an estimate for that change order, and I had an AutoCAD model to go off of. Now, we've been using Revit up until recently, so we didn't even know at the time that AutoCAD MEP had an Assemble add-in. So once I discovered the add-in, I quickly installed it, and he needed it ASAP. So I told him, I said, I'll see what I can do. So I opened up AutoCAD MEP, because if you open up one of their models in Revit, it doesn't give you the ability to see the type of piping it is or the size. It only gives you the fact that it is a pipe. So once I opened AutoCAD MEP and had the Assemble add-in, I pushed the button and crossed my fingers, and I was pleasantly surprised to see how well it did. I was able to open up the mechanical piping model in Assemble. It told me the size of the pipe, whether it was copper, PVC. It gave me the linear footage, and it gave me all the counts of each of the fittings and what type of fitting they were. I was able to send that out to the project manager in the field who was requesting it, and I called him a little later and said, was that what you needed? And he said, that is exactly what I needed. So something that would have taken them days to do, I was actually able to do in about 20 minutes, and that included the time to install the Assemble add-in. So with that, we'll move into our final case study, which is the manufacturing facility we mentioned. It was 1.4 million square feet, and this project was a design build, and we worked through these changes. Like David said with Montrein, design was changing as we were building. So we really had a challenge on our hands to work with that, and I'm going to hand it over to David to talk a little bit about what we worked through.
So one of the biggest changes, and one of the main ones that I focused on again, was the steel. The design team originally designed the building with massive amounts of steel, huge tonnages of steel. A building that's over about 1.5 million square feet required a pretty large steel superstructure. However, the components that go inside this building were never really accounted for. Some of the MEP systems inside this building, a 6-foot-tall man could stand inside one of these pipes and walk through, just barely scraping his head on the other side of the pipe. So there's some massive plumbing, mechanical, and electrical systems that power this building and that run through this building. Originally, those systems were designed to hang off the superstructure and the roof deck of this building. However, as the design went on and as construction started, they realized that once they filled those pipes with liquid, water, waste, anything that they were going to be used for, that the weight of those pipes would bear too heavily on the existing superstructure steel. So they decided to start adding additional steel, white steel, and supplemental steel that would hang off of the superstructure and would aid in carrying some of the loads of these systems. These changes were small, all the way up to half a million dollars worth of changes. The design team issued them as PCOs, as we issued those to our subcontractors. One of the big challenges here was that we were changing and adding steel across the entire building. So it wasn't one specific area that we were adding steel. It was across 1.5 million square feet, and it was happening weekly. So it was a real challenge for our estimators and our project team to really manage these PCOs. The changes would go out and be issued in designs or on the drawings, and we would receive the model, and then our subcontractor would provide us with a change order. And again, like you saw, it would be $5,000 to $500,000 worth of changes. So we would take the design team's model, we would select all the additional steel, give it a parameter using the comment field of what specific PCO it was, and then we would publish it into Assemble. Utilizing Assemble to track these PCOs, just like the bulletin, allowed us to compare what the area looked like before to what the area looked like now, to really see how much steel was added. and to really vet our subcontractor's number and to see how much additional tonnage the design team added. These PCOs added up to about 30, all in total, ranging from different prices, and it really saved the estimator quite a bit of time. I would say that 180 hours would have been doubled if they had to do all this by hand, and the time savings and how they were able to track and follow along with the subcontractor's pricing was really important too. Utilizing Assemble and utilizing these models to track these PCOs allowed us not only to vet and ensure that our subcontractor's pricing for these changes was accurate, but it allowed us to have an open discussion with that subcontractor. I think a lot of times we find that we get a number from a subcontractor and we think it's high, and maybe that's because they want to add more money to the job, or maybe that we're missing things. So I think it's important to share this information, share these changes and these tools that we're able to use with the subcontractor so that you can have a linear dialogue with the changes. And when changes come, it's not a huge surprise of what the costs are or what the amounts are. So in this case, we worked really well with our steel subcontractor. We had a couple meetings on site about what changes were already happening and what changes were coming. And that way when they came, we were able to identify them and take care of them in a linear fashion.
Thanks.
That's awesome, David. I'm going to jump in here for a second and kind of talk to that a little bit. Listening to you talk about that process and the collaboration that's happening there is huge. I know personally I've worked on managing estimates for PCOs and in a manual method before Assemble, and it is so time consuming and so tedious. And your point about a subcontractor number for PCO coming in high, our industry, the standard way of doing it is that the sub comes in high, the GC comes in low, and you meet in the middle. So when you're working off of the same information and collaborating to make sure that everybody's on the same page, you get rid of that, I'm going to make sure my number is high because I know he's going to beat me down. And,
right.
and vice versa, you know, having all of that information available and organized, you're really creating a very detailed audit trail here. And getting that information out in front of all parties ultimately takes away some of that the time requirement to just do the negotiation. So this I think is huge. I really like this workflow that you guys are walking through here.
Thank you.
Thanks. One of the things I want to point out after talking about these 4 case studies and talking through what we've done in the past 5 years, the case studies that we've shown you were 3 of them we received models from architects and engineers, and 1 we created in-house. I will tell you that this is the kind of thing that involves early planning. On some of these projects it was design build, so we as the CM had control over when we received models, receiving models as we got bulletins and updates and PCOs. There's other projects that we have where we've created the model in-house that the architect doesn't model, and we have to be responsible if we want to keep updating on bulletins and PCOs. We might create the model ourselves and publish it to Assemble so that our estimators have a good handle on those quantities, but then that model moves forward for us in the coordination aspect as well. So these models for us don't always come as pretty and packaged as the ones in these particular cases, but it is something that you want to start that conversation very early to find out what it is you're going to be receiving, how often you're going to be receiving it, and how you can utilize that model.